Remember this cheap power bank from a couple mailbags back? If you don't, I'll put a link up there to that mailbag. This thing was the biggest, cheapest power delivery capable power bank that I could find on eBay. As you can see, it has two theoretically USB 3 outputs, a Type-C output, I guess, micro, mini, whatever the hell that thing is, input, and above it there's an empty slot, which I think might be that Apple connector that nobody else uses, but I'm not sure because I don't have anything that will talk that. Then we have a little flashlight LED over there. We have a single button on the side. We have a little screen there, which, I get the light just right, has percentages on it. So presumably that lights up to show the state of charge. And then we have a spot for 3, 4, 5, 6, 7, 8 18650 cells in there. As you can see, the positive side is a complete metal strip that has them all in parallel. And on the negative side as well, they're all these spring type terminals, and they are all physically in parallel. So that being the case, you probably should use matched cells of known quality. Not going to do that. These are all salvaged cells from old laptop packs. I have tested them. I have charged and discharged them a couple of times. These ones are all between 2000 and 2400 milliamp hours in my testing. And they all seem to hold a charge, and they all seem to be relatively similar minus that capacity. And they are all currently charged to about 4.0 even. So it shouldn't cause too much, sparking or heating or anything else when we put them in here. But as you may remember from the mailbag, when I hooked this thing up, it didn't work, or at least it didn't seem to work. Now then, there was one or two people in the comments suggested that I probably needed to put the cells in and then charge it for a bit just to wake up the chip inside it. So I'm going to try that. But for now, I'm just going to take a quick peek, and I noticed some things in the listing that I probably should have noticed sooner. So here is the power bank that I got. This is the 18-watt power delivery quick charge version. And down here, they describe it as a large capacity 8x18650 batteries, not included, USB power supply module. The fast charging outputs are capable of QC3 and PD3 and can reach up to 18 watts. It claims that each battery slot is charged and tested separately. Now that is a blatant lie. As we've already seen, they're all in parallel, so they're not being managed separately. Something I was wondering about when I first unboxed this thing is the test mode. The first cell slot is marked as test, and it's suggesting when you install each battery for the first time, install a single one and press the button to test whether it's good or not. If the indicator light is on, the battery is normal. If the indicator light is not on, the battery is faulty. So that is something that I'm going to take a look at. Other than that, the output, the quick charge outputs 5 volts at 3 amps or 9 volts at 2 amps or 12 volts at 1.5 amps is what it claims. So we will also test that, assuming I can get the thing working. So just put one cell into the test position here, and again they're all in parallel, so it doesn't really matter, and push the button, and that does cause the indicator to blink. So I guess it's a good cell, which I already knew, but more importantly, I guess this thing can see it. But no matter what I do, if I hold the button or whatever, I can't get the flashlight to turn on. And if I plug in a light of some sort or a load, I can't get it to turn the output on. So let's just try this suggestion from the comments and charge it a little bit. We can see that it is actually doing something. It's charging up to somewhere between 75 and 100%. So now if I disconnect that, hey, we have output. And can I turn that flashlight on? No. Maybe it won't do it with that on there. Oh yeah, I can turn the flashlight on. It's like a 5-second long press. Okay. So this thing does work. Should we take it apart first, or should we test it first? Let's take it apart. That should be quicker, I think, just to see what's inside it. I'm going to need a spudger, probably, and I'm guessing that try in here, maybe? Oh, there we go. That's coming off. Oh, that came off easier than expected. Okay. So what do we have in here? Not too much. We have the LED there. That's one of those 1 watt style. We got some surface mount LEDs there. That's for this little display piece with the little light boxes in it. Nice. Other than that, we can't see many components on this side. We got a couple of Phillips screws, so let's pop it out that way. And if you yank these two, of course, they're self-tapping screws into plastic. They do come out quite easily, though. Let's see what happens. Does that pop out? Oh, right, I've got all these things holding it in, I bet. Oh, well, that was easy. Aha! More circuitry. We have the little switchy switch there. We have an inductor there. A reasonably beefy one for a surface mount inductor. Some kind of couple of transistory dudes there. And 2 chips. Oh, and then some more transistory dudes in parallel down there. Let me get closer to some of these and see what's going on. Start with the biggest chip first. That's an IP5328. I can't guarantee that I'm going to be able to find any of these data sheets, but we'll give it a shot. I couldn't find a data sheet in English, but I did find one in Chinese that I got Google to translate for me. It's not perfect, but we have a system on chip. We have USB, power supply 5 to 12 volts, 5 volts at 3.1 amps, 7 volts at 2.4, 9 volts at 2 amps, 12 volts at 1.5 amps. That is exactly what the seller's listing said. So it looks like it's doing pretty much exactly what this thing does. We have a Type C, a Micro B, and 2 Type A connections, which is exactly what this unit has. We have a button and an LED in parallel with that button. We have 4 state of charge LEDs, connection to the batteries with, what is that? Oh, that's temperature sensing maybe. Okay, well, we're not using that. And there is that inductor. Okay, so this thing does basically everything that you would expect it to do. Good thing I was able to find that main chip, because I haven't been able to find data sheets for either this little 6-pin dude here or this 8-pin dude here. But I'm gonna guess, based on the fact that this guy has a direct connection to one leg of these 3 transistors, which are in parallel, and they have a direct connection to the negative side of the battery. So I'm going to guess that this is battery protection over here. Now, this guy even could have a brother in parallel with him, but he doesn't. That's a reasonable enough assumption. I can live with that, and not without knowing the specifics. But it was nice that we were able to find this guy. And there's the inductor that we saw in the schematic. The 4 LEDs on the other side, the push button, everything else is pretty much exactly the way the schematic for this thing looked. So I'm fairly confident that I know at least enough about this thing to proceed. Not that, I actually needed to know a whole lot about it in order to use it. I'm just curious, and I always like to find out what's going on inside my electronics. So I will just quickly snap this back together, put the screws back in, and then we'll proceed to see if this thing actually does live up to the specs that we found. I'll just quickly toss all these cells in with all the disclaimers that I already put at the beginning, that I know they're not all the same age. I know they're not exactly the same capacity or internal resistance. I'm willing to live with that for now, just in the interest of cheapness. I'm obviously not going to use this thing for sort of an ongoing use, as it's going to be mostly used, as I said, for portable use when I'm using my battery-powered soldering iron. So now, connect it up to power to wake it up. The power management is telling it that it's somewhere between 50 and 75% charged, and it is charging, albeit slowly. But I think that's good enough for our experiments. Did that wake it up? Yes, it did. Okay, cool. So let's get some test things out here and play with it a little bit. What's in my box of USB stuff? We have a 1 or 2 amp load. This is my couple of resistors in parallel. I think that's half an amp at 5 volts. Yeah, I guess let's load this thing down and see what happens. Oh wait, let's grab my two USB tester voltmeter things as well. Maybe I won't use that one right off the top, even though it's got more detail to it. I'm going to use this one just so that I can plug multiple things in here. It does show that it's putting out 5.1 volts, so that's cool. I'll plug my load in, 0.94 amps. That's reasonable enough. Let's switch that guy to 2 amp mode, 1.86, and it's only drawn the voltage down a little bit, and that could just be because of the resistance in this cable here too. Let's try that with this one and see what it says, because this one doesn't have the extra cable in it. So right now it's showing 5.1 volts and 0.9 amps. There we go. Now we're drawing almost 2 amps, 1.9 amps, and still 5.1 volts. Okay, that's cool. Let's plug this guy into the Type C. Oh, they don't work simultaneously. Okay, so if I unplug that, oh, this thing needs a load on it. Okay, so there's 5 volts, and let's plug that guy in. Yeah, we got a half amp there. Now then, will it put an output with this thing also on there? Yes, they're all pulling. So I'm pulling half an amp out of the Type C and almost 2 amps out of the USB 3 Type A, and the voltage has not sagged at all. Let's see if we can do any better here. Let's try it with the big load. I am going to plug this in as well because this thing can control quick charge modes. But for now I just want to see where this thing maxes out. So right now I've got this thing set for 2 amps. And if we turn it on, it has no problem with that at all. Let's go into quick charge modes and try QC2 and just see what happens. So right now it's set at 5 volts. 9 volts it can do. 12 volts it can do. 20 volts it can't do. So that is basically exactly what we knew it could do. So just back out of that. We're still in 12 volt mode. It said it could do 1.5 volts at 12 volt mode. So let's try that. Yeah, it's drawing it down a little bit, but that could be the wires. See over here, it is still at full 12 volts. That's cool. I don't know why this thing says 0.9 amps and this says 1.5 amps. But this guy is telling me that there's 17.8 watts happening. This guy says it's closer to 12. Not quite sure which one to trust, quite honestly, but regardless, that's not too bad. Let's try bumping it up just a little bit. 1.75. Still doing it. That's 20 watts. 1.75 amps. This guy is saying 15 watts. Still, that's beating spec. That's cool. We'll do 2 amps. Oh, it drags it down pretty severely. But again, this guy says 11.6, so it is starting to drag it down. It is doing it though. That's 22 watts. Cool. I like it when something actually beats its printed specs. So we'll drop this back down to 5 amps and just see what it does. 2 amps at 5 volts, yeah. How about 3 amps? Yep. It's not really sagging down at all. That's good. Let's try 3.5 amps maybe? 3.6. Because that's just where it landed. No, it drags it right down. It can't do 3.6. Okay. Let's do 3.25 maybe. That beep is annoying, but I haven't figured out how to shut it off yet. No, 3 seems to be about the limit. It just resets the thing as soon as I try. Or actually, it doesn't. No, it doesn't reset it, but it does drag it down below 4.5. And that's what I've got set for a low voltage limit on this thing. But still, full 3 amps at 5 volts, that's not bad at all. and it's certainly better than I was expecting out of this thing when I first unboxed it and it didn't actually work. So finally, the real reason why I actually got this thing is to power this little USB powered soldering iron. And just for funsies, I'll plug it in through this power monitor so that we can see what happens. So right away, the soldering iron has told it to be a 12 volt device. Okay, turn that on, and it's heating up, drawing 1.5 to, oh, it's bouncing. It seems to be modulating its power draw between 1/3 of an amp and 1.5 amps. And on the iron, we can see the percentage power draw at any moment to try and get up to 310 degrees. Oh, and it's even showing that it's running on 12 volts. That's cool. Because this thing would really prefer to run at the 18 volt level, I'm just going to give it a second or two to come up to temperature. It's not smoking quite yet, but it is able to melt solder now. And yeah, it's kind of modulating itself in the low teens to 30s kind of range to maintain its temperature. I'm going to say that will do my job for me. It's a little bit bulky, but it is a lot more portable than pulling out extension cords to power this thing from. I mean, the other option for portable soldering is to use the butane powered iron that I got around here someplace, but I think this one's going to be just a little bit cleaner to use. One other thing I want to check is when this thing is charging, what happens. So it doesn't claim to charge from USB-C, but it does seem to. Okay, it didn't say anything about that. So it has bumped up to 12 volts. It's drawing 1.3 amps. I'm just going to let that go and charge up all those cells. You don't need to stand here watching this, I don't think. Yeah, we've been long enough. I think we've thoroughly explored this thing. There'll be a link down below to the mailbag where I got this thing if you want to see a little bit more about it. And the mailbag will have a link to where I got the thing from on eBay, although you already saw the eBay page, so you could find it yourselves if you wanted to. Let you know when I'm done, when I start rambling like that. Thanks for watching. Questions and comments down below. I'll talk to you later.